Hi, Matt. In case you didn't, I did not receive an attachment on the last email.
It should be a link to a Google Drive. It was too
Okay.
big.
All
So,
right.
But hopefully nothing will go wrong.
I doubt that it will. I've got it. You're right. Thank you.
Okay.
We got it covered.
Excellent.
Hey, Scott.
Yeah.
I just realized I haven't heard anything from David.
Oh,
I know he was on my list.
let me try to fix that.
Okay, thank you.
I just looked. It does come up live on Facebook now. So,
Oh, great. Okay. I was having a hard time finding it when I was looking for the older shows. I was having a hard time finding that. So that's great.
yeah, it just pops up. Looks like.
Okay.
Yeah.
Okay, good. We need to get this on the league's YouTube channel also.
Mm-hmm. Mm-hmm.
Hello, everybody. This is Scott Roberts from Explore Scientific and the Explore Alliance, and it is a distinct pleasure to introduce you to the Astronomical League their 13th program, Astronomical League Live. Terry Mann is the coordinator for this whole program, and she is here with me right now. Terry, do you want to get started, make some introductions?
Sure, I can do that. First thing, it was so nice to see an eclipse clip. It just brings back so many memories of when we were all in Wyoming at Casper, and just seeing the eclipse is just gorgeous, kind of a reminder. What I would like to do, I would like to introduce some of the people we have here. Some of them you already know, and I will do more introductions as the time gets nearer. But one new face we see here is Don Knabb. And actually around the league, he has been here for a while. He's not a new face to us, but he was the mastermind behind the ALCon website. He was the guy that had all the knowledge of how to put that together. And so he showed me, and I learned from Don, and I still have more learning on websites to do with Don. But he is also the chair of the Mid-East region of the Astronomical League. And Don, what states does that cover?
That is Pennsylvania, Southern New Jersey, both Virginias, West Virginia and regular, and DC and Maryland.
Yeah, that's
About 40 clubs.
That's nice. You got a nice sized region. Yeah.
We have the largest single club, I think, in the league, which is Novak, Northern Virginia.
Yeah.
It's like 1,000 people, I think, in that club.
Wow, that is huge. Yeah, and I know usually I can find you guys at StarQuest down at Greenbank, West Virginia during StarQuest having a meeting. I've sat in on those meetings a few times. So
Let's hope we do that again.
Hopefully we can do it this year. I hope to see that.
Mhm.
The next person you're going to see, the other two you see quite often, is Chuck Allen, which is the vice president of the Astronomical League. And he'll be doing some speaking tonight. And we've got Carroll Iorg, which is the president of the Astronomical League. And then we also, yeah, yeah, everybody keeps asking, are we going to be doing ALCon in Albuquerque? So we've all been saying that's something we'll look at as it gets a little bit closer and decide probably at the beginning of the year, I imagine.
We'll have a little more information here in just a few months.
Oh, well, that's good then. I won't say any more. And then we have Matt Penn, which I cannot wait to hear Matt's talk. I'm very excited about that. I'm really looking forward to it. So Scott, oh, hi, Matt.
Hi, Terry.
I like your studio. It looks like a radio broadcast room.
Well, we're all working from home these days, and so we've got more equipment than normal here.
Yeah, looks nice. You sound like a radio broadcaster. It just looks so nice.
Too many Zooms.
Yeah, yeah. Well, thank you, Matt, for being here. And Scott, hopefully David will be on shortly.
Yes, David just had to take care of some things, but he'll be on in a few minutes.
Okay.
He wouldn't miss an Astronomical League Live program. So
yeah, hey, we all get busy, and with it being December, I think that happens quite often.
Right.
Yeah. So,
but I'm glad you guys do these programs because you're able to reach people all over the world, and you're able to reach, of course. We started doing these virtual events because of COVID, the COVID pandemic and the lockdowns that people are experiencing. But what we found, and we've talked about this before, Terry, what we found is that there are people that, have to stay home because they're taking care of, they're taking care of someone, or they are just for various reasons unable to leave home. So they do astronomy maybe in their backyards, but to experience the Astronomical League live, talking to the coordinators and seeing all that the league can bring on, really has helped out a lot of people get more involved in the league's community. So I love that, and you guys do an awesome job.
well, thank you. You do an awesome job too.
I'm just connecting the wires. That's all. So.
You keep saying that.
I'm the guy behind the curtain back here. So
The
right.
wizard back there, huh?
That's right.
All right.
And I love it. So thank you.
Yeah, I think we all have a good time. That's something that every time we come on, we meet new people and talk to new people. So I think it's a great thing to do, and we do appreciate your help. So I guess we will go ahead and start. When David gets here, we will go back and talk to David for a few minutes.
Sure.
So, Carroll, I am going to jump right to you since you have an update. I'm curious what's going on.
I'm going to share my screen here.
Okay.
There is that Zoom, I'm looking to sharing my screen look, you know?
There you go.
Are you familiar with
Fingers
that?
crossed.
That's
Yeah.
right. Where is that button again?
Success at last, maybe. Yeah, I would like to echo what Terry's already said about our having so much help from Scott with keeping this.
You guys are
motion going.
being too nice to me, so.
Oh, no, not really. And on top of all the electronic stuff and all that kind of stuff, he also is a major sponsor for the league, including the almost brand new Fleming Imaging Award for young ladies. And also he continues and has been for lots of years underwriting the National Young Astronomer Award, the Peltier Award, and one of many things he actually does for the league. So we're very appreciative.
Oh, we are too.
Speaking of ALCon 2022, I've been in contact a few days ago with the leadership of the convention, and so far they're saying we're still on track for whatever is needed to pull ALCon 2022 off. They've been waiting in the wings for now 3 years, and they've assured me that they are very sure this one's going to work. So we'll see. Anyway, the dates, assuming nothing happens at the end, are July 28th through the 30th at Embassy Suites Hotel. It's a very nice facility, especially geared for conventions. It has a separate area, so it's a very outstanding event for that. There is the address down below for the website. The website will be available approximately January the 14th. And again, it's hosted.
Carol, we're not seeing any slides or anything if we're supposed to be.
Yes. Okay, well, let's see what's going on here, Terry. Okay, let's see here. Sorry about that. What about now?
Nope.
Seeing your screen now, Carol.
Yeah.
Let's get up here.
We got it.
Mhm.
What about now?
Yep.
Okay.
Yeah.
All right. So there's the slide for 2022. It's going to be held at Embassy Suites, like I said earlier. And so be looking at our webpage around January, the middle of January, something like that, for more information. But we anticipate registration will be available toward the end of January. So that's the goal. We'll, of course, check with the proper officials there, the state officials. They've been very strict over the course of this pandemic in the state. So the last I heard, it's fairly much back to whatever is normal in this time we're in right now. So we'll go with that, hopefully. And then once we get past 2022, the following year, we're going to Baton Rouge, Louisiana. And it's appropriate for that part of the world to call it astronomical gumbo, because they've assured us that even though the middle of the summer is not exactly when the natives like to eat gumbo, they're going to have it available just for us. So I think it's going to be an outstanding event. We haven't been in that part of the country for many years, so we're really looking forward to it. So hopefully everybody will put it on their calendar. We can do more than just put it in pencil, hopefully in ink for 2023. Here's some miscellaneous announcements. The first one is we expect our new website to be up approximately January 31st, give or take a little bit. The other thing is we are a major distributor for the RASC 2022 handbooks. They're now available from League Sales. So if you haven't ordered yours yet, get on the League website to link to the store and get that ordered. The other thing we would also encourage you to buy for a Christmas present for someone in your family or friend is one of the 2022 AL calendars. It helps provide the funds for ALCon Junior, which is scheduled to debut at ALCon 2022. And there's the address for the store, store.astroleague.org. And shortly after we have the website up, we'll have the postings for all the award information to make sure that people have an opportunity to get those awards submitted in a timely fashion. And we're looking forward to it. We had a large amount of submissions last year, and thanks to Vice President Chuck Allen and others who really made that happen and in a meaningful way. And so we're looking forward to that again. And at that point, I will turn it back to you, Terry. I think that's all for
Okay.
right now.
Well, thank you, Carroll. That's exciting to hear that we will probably all be in Albuquerque in July. I'm looking forward to that.
Yeah, that's the plan.
Definitely. David,
Yes, Terry.
there you are. How are you, David?
Forgetful, but I'm here. I'm
Hey.
sorry about that.
No worries. We're just glad to have you. How about if I let you go ahead and start us off officially?
Well, thank you, Carol. Thank you for your wonderful report. I have a question. Can I go to the Albuquerque meeting, Carol?
I think you should go. Not only you should go, but you must go.
Yeah.
Why must I go?
Now, I understand you did a trial run of Albuquerque, a couple of weeks ago, or maybe around
Yeah.
Thanksgiving.
Yes,
And so you have prepared it to where it's safe for the rest of us to go, right?
yes. It is safe for the rest of us to go. We have to be masked, and we have to have lots of duct tape around us. But I think it's going to be safe. Anyway, I'm really looking forward to that meeting. And I'm hoping I might be able to say a few words at that meeting.
I have a feeling we could work that in a meaningful kind of way. Yes.
I would like that very much. The other thing I want to mention, I do want to apologize for being late, but as I get older, I'm starting to get a little bit forgetful, and I just got turned around, and I'm sorry about that. And I'm here, and I'm sorry I'm late. And Scotty, thank you so much for calling me and
Oh.
yelling at me.
Oh yeah, I yelled so loud, it was crazy. So.
Yeah. Anyway, I'm glad to be here, delighted to be here, looking forward to the presentation. And I do have a quotation today, which I'm going to try to do, and I'm going to try to do it better than I did yesterday. I was doing it on a radio program yesterday, and the host, after I was done, said, "Don't quit your day job." So maybe I'll be a little better today. It is the Christmas season, and we have Comet Leonard in the sky. I was able to see it. I got a picture of it, not as good as the other ones that I've seen are, but I do have a picture. And yes, it is greenish. And in honor of that comet, I'm going to do a slightly rewritten version of A Christmas Carol for you tonight. And it goes like this. Said the night wind to the little lamb, "Do you see what I see? Way up in the sky, little lamb. Do you see what I see? A comet rising in the morning sky, with a tail, oh, not quite as big as a kite, with a tail as big as a kite." And now back to you, Terry. Couldn't have been that funny.
It was awesome. It was awesome. How did I know
Sounds
comets
like-
were going to make it into that song?
It sounds like David just guaranteed us a decent comet to observe.
Yeah, that's
That's
right.
right.
Yeah,
We have this official.
there's some great
Yes.
images of Comet Leonard right now. So
Yeah. Thank you,
I've seen
David.
it
That
3
was
times
great.
now, and it's a thanks, Terry. It's a beautiful comet, and I've seen it now 3 times on 3 mornings. And the 3rd time I saw it in the finder of my photographic scope, couldn't get a picture of it, but I did see it in the finder of the scope. So that's really, really good.
That's fantastic. Well, thank you. That was so original. I really enjoyed that.
Well, thanks, Terry. It's good to hear.
All right. How about if we go to Chuck Allen? Now, we always talk about Chuck. Now, what we say is, okay, Chuck is currently the vice president of the Astronomical League. But I would like to tell a little bit more about Chuck because his history is really amazing. He is a past president of the League from 1998 to 2002, and he founded the League's National Young Astronomer Award in 1991. He received the G.R. Wright Award for service in 1998 and holds the League Master Outreach Award and its Master Observer Gold Award. Chuck coordinates 3 observing programs and co-chaired ALCon 2021 virtual. He's a past president of the Louisville, excuse me, I never say it right, Astronomical Society, and is currently program director of the Evansville Astronomical Society. He is a former league judge in Earth and Space Science for the International Science and Engineering Fair. Chuck is a graduate of Duke University and the University of Kentucky College of Law and served as a U.S. Air Force officer. He was also a partner in Kentucky's largest law firm for 27 years. So Chuck, thank you for being here. It's always a pleasure to see you again. So I will let you start your talk.
Okay, thank you, Terry. Thanks very much for that introduction, which some of which means I'm just old.
I think it means you're talented.
Yeah, so anyway, let me go ahead and share screen now, if I may. We're going to talk tonight about unusual stars. And let's see, slideshow. Current slide. Everybody see that okay?
Yep.
Now, some stars are unusual for reasons that do not necessarily mean that the stars themselves are unusual. For example, we have stars that are unusual simply because of their proximity to us. This is not obviously a 3-dimensional image, but it does show neighborhood stars, stars that are closest to us. Proxima Centauri here being the closest. It orbits 2 sun-like stars, Alpha Centauri A and B. There are a number of red dwarfs around, as you can see, that are close to us, but the bright stars that we see close by are stars like Sirius at about 8.5 light years, Altair out here at 16.7 light years, Procyon here at 11.4 light years. So this is our neighborhood in the Milky Way. But let's focus a little bit on Proxima Centauri. This star here is actually 2 sun-like stars, Alpha Centauri A and B. And the little red dot you see in the middle of this red circle is Proxima Centauri, which orbits the 2 sun-like stars up here. And it orbits at a distance of 0.2 of a light year. So it takes 550,000 years for Proxima to make a loop around those 2 brighter stars. Interestingly enough, Proxima has been confirmed. This is a close-up taken by the Hubble Space Telescope of Proxima. It's a red dwarf star, and it has 2 confirmed exoplanets. But first of all, let's look at its size. It's really not a whole lot bigger than Jupiter and would fit neatly between the Earth and the Moon, as you can see here. The star has about 1.2 times the mass of our sun, and Earth masses rather. And I'm sorry, I'm talking about the planet now. Here, let me show you first of all the orbits of the 2 planets around Proxima. This is Proxima B and Proxima C. Proxima B is the interesting one. It is about the size of the Earth, just slightly more massive, 1.2 times the Earth's mass. Sorry for the confusion a moment ago. And it, interestingly enough, lies within the habitable zone of the star Proxima itself, which means that water could exist on the surface of Proxima b in liquid form. However, as interesting or enticing as that might be, unfortunately, being a red dwarf star, Proxima is a flare star, meaning that it has significant ejections that would shower this planet with extreme radiation at times and make life there probably not feasible. But what if we were to visit the Alpha Centauri system? What if we were to land on Proxima b and look back in our direction? What would we see? We'd still see Cassiopeia looking like it does pretty much from Earth, but we would see one more star in the field of view, a 0.4 magnitude star right in the vicinity of some nebulosity. And interesting enough, if we aimed a telescope at this star, this yellow star here, the sun, we would see it embedded in the middle of the Heart and Soul nebulae, just like this. So if there are astrophotographers in the Alpha Centauri region, undoubtedly this is a major target for them. How long would it take to get there? Well, we know, for example, that the Voyager 2 spacecraft is traveling at about 34,000 miles per hour. It took 2 years to get to Jupiter, 4 to Saturn, 9 to Uranus, 12 years to pass Neptune. What if it were headed toward the Alpha Centauri system? It's not, but what if it were? How long would it take to travel the 24.7 trillion miles to get there? And the answer is 96,500 years, roughly 15 times the entire length of recorded human history in order to arrive there. That gives you some idea of the difficulties involved in interstellar travel. Looking at a couple of nearby stars, we see Sirius. Sirius is a very interesting star because it's not only the brightest nighttime star, but it has a very significant role in our ancient history here on Earth. For the Egyptians, the heliacal rising of Sirius, its first appearance in the morning before sunrise, hearkened the flooding of the Nile, which was a very important date for them in terms of agriculture. And also, Sirius is known as the dog star. It's the brightest star in Canis Major, the large dog. And the Egyptians referred to it as the dog star. And from this, we get something called the dog days of August. And what that means is that in mid-August, the Egyptians knew that Sirius was in the sky somewhere near where the sun was located in the sky. And in fact, that's true. And they thought that the heat from Sirius combined with the heat of the sun to make those days particularly hot. So when you hear the term dog days of August, it comes from the star Sirius. And interestingly, the word Sirius in Egyptian means scorching. So that's the origin of that term. Moving out to 79 light years, we come to a very interesting, slightly larger star called Regulus, which spins every 16 hours. Its spin axis is relatively perpendicular to our line of sight to the star. And as a result of this, the spin rate of Regulus is only 15% slower than the rate that would cause the star to fly apart due to centrifugal force. Vega 2 is very oblate. It rotates every 12 and a half hours. And we look down on its pole. So we see it as fairly round, at least in terms of studying the star with professional telescopes. We don't really see its disk, but it would appear round from our perspective. And so the star seems larger to professional astronomers than it actually should, simply because it's so oblate due to its rapid spin. We come to a larger star still, Arcturus, 36 light years away, about 25 times the sun size. And very interestingly, in 1933, the light from Arcturus was used to start or to illuminate the 1933 Chicago World's Fair. This was done using the 40-inch refractor at Yerkes Observatory and a photomultiplier, which they're looking at here in this photo from Yerkes Observatory. This was in turn converted to an electric signal, which opened the fair by turning on the lights at the World's Fair in 1933. So we've looked at a number of stars. We get even larger still. We look at Spica and Virgo. And what you're seeing when you look at Spica is actually 2 blue giant stars in a double system. And so when we look at the non-giant northern stars, you'll note that these are all familiar stars to you. They're the bright stars you see in the night sky, and most all of them are bigger than the sun by a considerable amount. That's not a coincidence. There are actually countless stars that are closer to us than these stars that are red dwarfs and hence faint, like Proxima, which is the closest star to us, and you need a telescope to find it and a lot of good luck. And nonetheless, these bright ones we do see, and they dominate the night sky. But let's reduce this scale right here to this, with Capella being at the upper end, and look at some larger stars still, like Aldebaran, Rigel, Deneb, Betelgeuse, and Antares, the latter 3 being red giants, Rigel being a blue giant star. Looking at Rigel in Orion, of course, we see a star that lies at 860 light years, and yet it shines with tremendous brightness. It's 70 times larger than the sun and has a luminosity that ranges somewhere between, or is thought to be somewhere between 80 and 360,000 times the luminosity of our sun. And it has between 18 and 24 solar masses. It actually has a triple star companion. 2 of the 3 stars and its companion pair are easily visible in amateur telescopes as a single second star in the system. Now, this star, amazingly, is only between 7 and 9 million years old. Our sun is 5 billion years old, at least. This star is burning its fuel so fast that its lifetime will be merely a blip on the lifetime of the sun. Deneb in Cygnus, 2,600 light years away, and yet we see it as a first magnitude star in the sky, 200,000 times more luminous than our sun, and amazingly 200 times larger. But they get larger still. This is an actual image of the disk of the star Betelgeuse in Orion. As you can see, superimposed on the size of the solar system here, that this star would actually extend almost to the orbit of Jupiter. It's so large, but small compared to this star, VY Canis Majoris, a hypergiant, lies at a distance of almost 4,000 light years and is 2,100 times larger than our sun. Here, the scale is the sun, Earth distance, Mars sun distance, Jupiter sun distance compared with the size of this incredible star. Is it the largest one we know of? Not even close. This star right here in the middle of the screen is called Stephenson 2-18, lies 18,900 light years away, and it has a diameter of 1.8 billion miles. It's this much larger than Antares. And if you want to compare the size of Stephenson 2-18 to the Earth's orbit around the sun, here it is. This distance between the dot and the edge of this disk, 93 million miles by comparison. Well, that's the largest star we know of, but what about the largest apparent size star? What star looks the biggest to us from Earth, other than the sun, of course, which extends over half a degree seen from Earth? The answer is not Betelgeuse, but actually R Doradus, which extends or subtends an angle across its disk seen from Earth of 0.57 seconds of arc, about a 20th of a second of arc. And you can see it's actually a little bit larger than Mira and Betelgeuse both. And I have simply a disk representing how big Pluto appears from the Earth to give you some idea of how tiny stars do appear in the sky, these 3 being the largest apparent angles of any stars we see. They're also very small stars. The remnants from stars that have reached the end of their lives, stars below 8 solar masses, which end their lives by forming planetary nebulae and leaving white dwarfs behind. These are Earth-sized stars. The escape velocity at the surface of a typical white dwarf star would be something on the order of 1,000 times higher than the escape velocity from the surface of the Earth. But they can get even smaller. In the case of supernova explosions, they can cause a neutron star to form at the center. These might be only as large as 6 miles across, and yet have between 8 and 25 solar masses associated with them. And again, these are left over after a cataclysmic collapse of a star into a supernova. An especially powerful supernova might actually reduce a neutron star to a quark star, where the neutrons themselves are torn apart, leaving only quarks, free quarks in a star that might be less than 6 miles across.
Wow.
This is a hypothetical star, although one has been theoretically detected. It's located, you can't really see it. It's not either of these two dots you see inside the circle, but it's a little smudge in between them. And this is called XTEJ 1739. It's 39,000 light years away, and is thought to be approximately 7 miles in diameter and believed to be a quark star. Obviously, we could talk about variable stars all night long, and we're not. I'll just casually mention that we have unusual stars because either they are pulsating variables, are caused to pulsate by virtue of the fact that they will collapse, cause fusion to increase at their cores, and then that radiation pressure will cause them to expand again. We have cataclysmic variables where we have maybe a white dwarf star and a host star that donates hydrogen to the nearby white dwarf. As the hydrogen accretes around the white dwarf, it heats up, reaches fusion temperature, and causes a flare, which we see as a cataclysmic increase in brightness. We have eclipsing binaries like ALCon, where one star eclipses another, causing the brightness of the system to change. And we have rotating variables. These are stars like HD 12545 seen here, which has a peculiarity. It has the largest known star spot of any star we've observed. That spot you see there is larger than our sun, and it causes a variation in the brightness of the star as it rotates. We know stars have colors. We've seen the categories of colors of stars ranging from red stars like M and K class, orange stars, yellow G class stars like the sun, white stars, blue giant stars. Well, there's something missing here. Where are the green stars? Why don't we see any green stars? Well, interestingly, it has to do with us more than anything. It has to do with the photoreceptors in our brains, in eyes that see, rather, blue, green, and red. And what happens when you have a star that is dominant in the blue dominates over all the other colors, and we see a blue star. If you have a star that dominates in the red, we see it as red because it dominates over the other colors. But when we see a star whose peak intensity is in the green range, we also see heavy colors on both sides of it, blue and red, which combine with the green to give us, of course, what? White. And so we see white stars in between, we don't see green, and that's the reason for this. As far as stars that have lots of planets that we know of, we used to be the record holder with our 9, but we went and demoted one. And so we fell into a tie for first place with the Kepler 90 system, which has 8 known exoplanets orbiting it. And so we blew that record. And we move out now to the furthest star that we've ever observed other than a supernova. And this star, if we zoom in between in this galactic image here, we see a star here in the lower right. And this is a blue giant called Icarus. And it is 9 billion light years away from us. It's in a galaxy 9 billion light years away in terms of light travel time. That's how long the light took to reach us. That is not a supernova. It is simply a blue giant star. It's the furthest single star that we've ever observed to date. The fastest spinning star is a pulsar, seen here in this image, that spins at a rate such that the equator of the pulsar spinning at 24% the speed of light. That's 156 million miles per hour at its equator. The hottest known star, embedded right here in the middle of this cocoon, is a Wolf-Rayet star, 102 in Sagittarius. It has about half the sun's diameter, and its surface temperature, though, runs at about 378,000 degrees Fahrenheit. Most sun-like star is 18 Scorpii. And look at how similar it is. Same mass as the sun, same luminosity as the sun, same diameter as the sun, virtually the same surface temperature, almost identical rotation rate, and the same age. So if you want to see a star that looks exactly like the sun, look for 18 Scorpii. It's easily seen in binoculars. And finally, the fastest moving star yet detected lies at the center of our Milky Way galaxy, orbiting the black hole at the center, and it's moving at approximately 8% the speed of light around the unseen black hole at the core. And so those are just some unusual stars that I thought would be interesting for perhaps people who are new to astronomy, and I hope I covered enough of the range to give you a feel for how different they can be. Thank you.
That's pretty amazing. All right. Well, thank you very much, Chuck. We appreciate that. And that was very interesting. David, we need to go back to you for a minute. You wanted to speak about a project going on. You're muted.
Muted, David.
Yeah. Hello, everyone again. I first of all wanted to congratulate Chuck on a wonderful presentation. The one thing that I found was the distance to Deneb. So I quickly looked it up and I found that Chuck is absolutely right. The distance to Deneb or from Deneb is very difficult to figure out. But what Chuck said in his presentation is correct of what we know now. Chuck, thank you very much. I really learned a lot from your talk tonight.
Thanks, David.
But I want to talk very briefly right now about the Junior Astronomical League. I believe, and I've spoken to Carroll about this and others, that it is a central mission of the Astronomical League to reach out to the next generation. If you go to almost any of the club meetings of member societies in the United States, a lot of whom are members of the league, you will find a lot of people like me, older people, more forgetful people, and not a whole lot of young people. I would like to help to change that. And with the blessing of Carroll and other people in the Astronomical League, we are starting the Junior Astronomical League. It is a part and parcel of the Astronomical League. Right now, it's meeting only online the second Sunday of every month, which means we met last Sunday. We're not going to meet in 2 days from now, but a week from this Sunday, we will be meeting again. I would like to encourage as many of you to come to that meeting. And if you're interested in coming, and even more than that, if you're interested in bringing young people to this meeting, because it's really for young people, would you send a letter to Terry, an email to Terry, and then I will arrange to send you the link for that meeting when I get it. We want to get the next generation interested in the night sky, not to become astronomers, but to just sit out and enjoy the night sky. I think that's the most important thing to do. Look for meteors, look at the moon through a telescope, just enjoy it. If we can accomplish that, I think we've really hit our stride as a major astronomical group. Thank you, and back to you, Terry.
Okay, thank you very much, David. And you are going to see my email address all over the 3 questions that I'm going to ask next. So,
And I posted it in chat as well. So.
Okay, thank you, Scott. All right, so these are going to be the 3 questions for this show. And as you can see, the door prize will be a 2022 league calendar. And so answer the questions just as quickly as you can, because by the end of the program, I will announce the winners. And someone from the Astronomical League will be contacting the winners. So there's my address. Please send your answers to secretary@astroleague.org. And here are the questions for tonight. We've been talking a lot about Comet Leonard. What Messier object did Comet Leonard pass this morning? And I've got to tell you, that image is from Barbara Harris from this morning. That's gorgeous. Yeah, from Florida. So what Messier object did Comet Leonard pass this morning? Next question. There is a famous supernova remnant in Taurus. Name that remnant. And again, secretary@astroleague.org. Last question. Are stars born in groups? Is that true or is that false? Answers to me, secretary@astroleague.org. All right. I'm going to end this and we are going to move on to Don Knabb. All right. And again, welcome, Don. It is nice to have you here. I know you were here probably a few shows ago. I think you were here.
Yep.
And thank you for coming tonight.
Sure.
So Don's earliest memory of the sky is seeing Cassiopeia in Cub Scouts, and he has loved the starry night ever since. He's primarily a visual observer, but at times tortures himself with astrophotography. He has been a member of the Chester County Astronomical Society, which is about 20 miles west of Philadelphia, since 2006, and has served as an officer for most of that time. His favorite observing site is Cherry Springs State Park, where he and his wife camp with other club members. He observes with several telescopes, but his favorite device is its 120 millimeter binoculars, although he also treasures the view of Orion's Nebula and Carolyn's Rose in their 12-inch Dob. Now, Don, as I mentioned earlier, is also chair of the Mideast region of the Astronomical League, and he did set up the website for ALCon Virtual. I am pleased to say that Don will be joining our rotation for the Astronomical League's Global Star Parties starting in January of 2022. So tonight, he's going to speak about the Constellation Hunter Observe program that the Mideast region has been encouraging their members to pursue. So Don, thanks again for joining us, and I'll turn this over to you.
Okay, well, let me share my screen and I will get us going here. Can you see my screen?
Yes.
Yeah.
Okay, so I had a Zoom talk with Phil Whitebloom, who's president of the Howard Astronomical League of Central Maryland. And we talked about what could we do to get new members. So many clubs have new members. I think our club has probably grown by like 30 members in the last year that I'm in. I know another local club, Delaware Valley, has grown by more than that. They're at record levels. We're at a record level. And I'm here all over the league. So we said, how can we get these new members to do some of the programs that the Astronomical League offers? So I put this together. I've already presented to a couple of clubs, and I have some more lined up. So let me just go through. And this is for really aimed at new members because we have so many. So I did a just very short introduction because a lot of people don't even know what the league is, but it's composed of 300 societies, 21,000 members. This is a picture of the current website, soon to be replaced. And we are divided into these regions. And the one I am chair of now is this little one over here on the East Coast. And it is the Mideast region. And so we call it Merrill. I didn't even know what Merrill meant a couple of years ago, but then I found out because this guy down here, Terry Trees, wonderful man, was the chairman. And this is from the league website, which is going to be updated soon. He did a great job being chairman, and so I follow in his footsteps. Al is still regional representative. We're about 40 clubs: Delaware, DC, Maryland, Pennsylvania, half New Jersey, and the 2 Virginias. So a lot of people, a lot of new members don't even know what Merrill and what the Astronomical League is. So, and most, if not every member of these clubs can participate in these observing programs, 60 observing programs, and they're a lot of fun. So talking with Phil, we decided that we'd pick one of these to work on throughout the league, throughout the Merrill group. And a great way for people to enjoy astronomy is to learn the night sky. And even more for not just new members, but any longtime member who doesn't really know the constellations. Great way to expand your skills. So the Constellation Hunter program has northern and southern skies. Of course, we will do the northern. And the purpose is to provide an orientation to the sky. There's nothing, I enjoy nothing better that once you learn the sky, and the seasons roll around, when I see Orion, it's like an old friend coming back to visit me for the winter. In the springtime, when I see Leo the lion, it's like, hey, there's Leo. Haven't seen him in a few months. It's a really wonderful thing once you get to know it. We picked this program because you really need almost no equipment. I mean, there's a couple of things that will help you, but all you really need is a sky chart and a reference for the brighter star names. And then the objective of the program, provide a forum to learn the brighter stars, the constellations, learn how to navigate, provide a solid foundation to go on to the other programs. And again, it's like I said, the constellations become your friends, and it's a really wonderful thing to experience. So easy to get a sky map. There's this one every month from skymaps.com. There's also another site, I think it's called What's Out Tonight. You can get a sky map every month for free. Binoculars may not be required, but they certainly would help. In light blue skies, they would certainly help. And but you only sketch the main stars. We got to keep this easy. It's really not complicated. I was out under the stars, our club had an observing event, and one of our members was working on it, and she was working way too hard. I said, just get the major stars. The idea is to become familiar, not to be an expert. And you can get all the information we need on the Astronomical League website. Everything is here. It's not hard to find under observing programs. And here's an example. Now, you can tell this is what you need to do. Observe and sketch all the northern constellations. Obviously, you look at my sheet, you don't need to be an artist. Okay. Dimming red flashlight would certainly be a lot of help. A clipboard would be a lot of help. And now it can take a year. Why? Because the constellations differ as we go around the sun. But here's another idea. You can, if you don't mind dressing up warm or find a warm night in the winter, you can capture a lot of these in the winter. And I'm going to show you how. So I'm hoping this comes through okay. This is a screen capture from Stellarium. So this is on the middle of December at 6 o'clock. Okay, it's the middle of December. It's almost winter. So what do we have here? We have the summer triangle. The summer triangle is still up because the sun is setting so early. So you can get all these. You may not be able to get Hercules, probably just miss that, but you can get so many of these, Delphinius, Sagitta, Cygnus. You can get all these summer constellations in December, okay? And then you go back in and warm up. Come out about the same night, about 9 o'clock, right? And what do we have here? Here are the winter constellations, Taurus, Orion, Cetus, Aries. You can get all of these pretty quickly. Just a matter of making a sketch. Go back in, hot chocolate, warm up, come out about midnight, and here are our friend Leo leaping up from the east. So you go from the west to the south to the east, and from 6 o'clock to 9 o'clock to midnight, and you can get all these constellations. You can probably cover 3/4 of the list in December if you really try. So here's a log sheet that you can get from the Astronomical League website. Okay, it can be downloaded. Or I made one up that I think is maybe a little bit more useful. It's this one, and I'm going to show you how you can get that. Okay, I did send it out to all the Mideast region ALCors, but I'll show you how you can get this sheet. This gets you on 2 of them on one sheet, and has these things you just have to circle the seeing and transparency. Make it a little easier, especially since you're probably going to have gloves on if you're doing this in December. Make it easy as possible. So 39 constellations, and this is the list. You can get it from the Astronomical League website. Oop, one back up. And when you complete it, here's what you get. You get a nice certificate, a pin. You get your name in the reflector, and you probably can't see it. This is my certificate from 2009. And I know you can't see this, but there's signed by someone called Terry Mann right there. Okay, let me show you one other page if I can. I'll switch this and I will show you one other page, and that would be this. So here is the Mid-East Region Astronomical League website. And if you go to if you search for merrillastronomy.org, and there's a quick link to Constellation Hunter resources. And here's everything I just told you is here. There's where you get in your reflector. And here are directions, and here are the links. This is the web page on the AL, the sky map from sky maps, the sky map from what's out tonight. Here are log sheets in Excel or PDF format. And Astronomy Magazine had a nice web page on learning constellations. So I know there's several clubs in the region that are working on this, and it's going to be fun to see a lot of names in the reflector next spring.
Well, thank you, Don. That's really amazing. You know, a lot of times our club originally started on the Messier binocular list, and we would all get together out at our local club observatory and work on that. And it's so much fun when you're working with a group of people and you're all working on the same thing.
Yep. Now, one thing I'm going to show you. So a flashlight like this is really helpful. This is a dimmable Rigel flashlight. And binoculars, the best binocular I found for doing this are these 2-power binoculars. They look pretty goofy. They don't magnify much, but they make your eyes so much bigger. You can see all the faint stars. So, and these are inexpensive. A couple people, I think they're all made probably in the same factory, but a few people are selling them.
Yeah, I just bought those.
They're
Those
great.
are
I
amazing.
love
We
those
only had them a
binoculars.
short time.
They're
Yeah.
the greatest thing, really.
Yeah, they're pretty amazing. So thank you. That was very
Sure.
informative, and hopefully a lot of people will look at that because it is a great way to learn the sky, especially when you're new or if you need to brush up on the constellations. Definitely will help you, and you can earn a certificate and a pen. So
It's
that's
a
all.
great way to make some friends in the sky too.
Yeah, I'm like you. When I see Orion, it's like seeing old friends because you don't see them for so long.
Yep.
So just
Yep.
seeing the constellations. So, all right. How about if we take let's just take a 5-minute break. Does that sound good?
Sounds good.
And we'll come back with Matt Penn and his talk. So we'll just break for 5 minutes. Thank you.
Well, we are back. And what do we have next here, Terry?
Next, we have Matt Penn. Matt, welcome. I thought I was muted for a minute when I saw that banner go up. All right. Matt Penn got interested in astronomy when his parents bought him a telescope while he was in 3rd grade. He got his bachelor's degree in astronomy from Caltech and worked at Caltech's Big Bear Solar Observatory for 2 summers. He was awarded a master's and PhD in astronomy by the University of Hawaii and did his dissertation research about oscillations in sunspot umbrae, using the Mees Solar Observatory in Maui. In 26 years of solar physics research, Matt worked at solar observatories in New Mexico, San Fernando, California, and most recently, Kitt Peak near Tucson. He has published many papers and worked with many excellent students. In 2014, Matt developed the Citizen CATE Experiment for the 2017 total solar eclipse. The collaboration involved 286 volunteers and included 117 students, from graduate students to middle school. The results of CATE were published in 2020, and now Matt is working with friends and colleagues on a follow-up project entitled the Dynamic Eclipse Broadcast Initiative. This talk will describe the improvements being made from the lessons learned at the 2017 eclipse, the initial results from the DEB Initiative Core Group, and how you can get involved in the Dynamic Eclipse Broadcast Initiative today. Welcome, Matt. It is a pleasure to have you here. And thank you for speaking with us tonight. This sounds like an amazing opportunity.
Well, we hope so. And thank you for the opportunity to speak to your group tonight.
Sure.
Let me pull up my slides and try to share. And that's not the way to do it.
There we go.
Okay, oops, sorry. Here we go. Back to slide 1. All right. Hopefully you can see the title page now.
Yes.
Excellent. So if I was going to summarize my talk, I'd say that I'm going to offer 2 invitations. And the first one is right here on the cover page. But to get to the second one, you'll have to listen through the whole talk. It'll be on the last page of the talk, the last slide. So as Terry said, I'll be talking about the Dynamic Eclipse Broadcast Initiative that a small group of us have started. Here's my name and my email. Hopefully it's pretty straightforward. If you wanted to contact me, just jot it down. My astronomy affiliation now is with the Tucson Amateur Astronomy Association. And this cover page is an image from Kevin Cook taken from their dark sky site. It's the Chiricahua Astronomy Center outside of Chiricahua National Monument. So here's my first invitation. The TAAA is building several member observatory sites, and I'm one of the people who's really excited to build a remote site here in the dark skies in southeastern Arizona. The TAAA has a few more sites available in their master plan and looking for people who might be interested. So if you have any interest in putting a telescope under excellent skies like this and remote controlling it from your house, send me an email or contact the TAAA, or I can put you in touch with people, the right people to contact. Okay, so now for the second part, and there's a little bit of a longer story involved with the second invitation. And if you're Snoopy fans, you all know that a good story starts out with, it was a dark and stormy night. So here we have a group of students that I learned to love and really work closely with from a local high school here in Tucson, Cienega Astronomy Club at Cienega High School in the Vail School District. Jack Erickson is the lead for the club, and David, you know Jack Erickson very well. In this picture, he's looking really stressed out. He and I had worked with the students for several months, training them to take eclipse data during the total solar eclipse in 2017. And on the day of the eclipse, when they got to their site in Nebraska, they were greeted with weather like this. They had been followed by the Discovery Channel through all of their training. And here you see the Discovery Channel filming them under cloudy skies on the day of the eclipse. So he and his students were under some stress, and it didn't get any better as time went on that morning. About 2 hours before totality, it started raining. And so here you see them huddling over the telescope, trying to protect it from getting wet, and maybe some dangerous situation with wires in puddles here. But why did I put these guys through so much torture? And why did Jack send his students to Pawnee City, Nebraska from Tucson to see the eclipse? Well, I have to get into why it's useful to study a solar eclipse from the ground. So when we study the corona of the sun, it's about 1 million times fainter than the disk of the sun. And to do it from the ground, we build special telescopes called coronagraphs. Now, it's a little bit more complicated than this figure that I'm showing, but we're basically doing the same thing that you see on the left-hand side. If you're sitting in your living room and you raise up your thumb and blot out a light across the room, you get the light blocked from the source directly, but you can see dust particles. You can see bright particles as light scatters off of dust in your house. Hopefully your house isn't as dirty as this figure. But the idea is that when we're trying to observe the corona and blocking the disk of the sun from the surface of the Earth, we get the same effect. Light scatters off of molecules of nitrogen or dust molecules in the atmosphere of the Earth, and we can't really see the corona. You can see the background wall isn't very well defined. But what a total solar eclipse does is it basically takes your thumb and it moves it into space. So the moon obviously is above the atmosphere of the Earth, and as it blocks the bright light from the disk of the sun, it also creates a shadow, and so the atmosphere of the Earth doesn't scatter any of the light. The background is reduced by a factor of about 10,000 over what we can do from a good site with a good coronagraph. So solar eclipses are really special, and we wanted to take advantage of this during the 2017 eclipse, and we're hoping to do the same thing in 2024. Now, I know you guys are up on astronomy, so you're saying right to yourself right now, well, doesn't NASA study the corona from space? And the answer is yes, but NASA can observe the solar corona on the disk of the sun. And here's an image from the SDO spacecraft, the AIA instrument. And it images the solar corona, which is about 2 million degrees Kelvin, in very hot lines, lines in the UV part of the spectrum, or the extreme UV, EUV. And we can see the magnetic field lines on the disk and a little bit off of the limb of the sun, but not very far. Another instrument from NASA on the SOHO spacecraft called LASCO C2 can image the corona, but it does so only at 3 solar radii and further out. Here we're looking at, in the LASCO field of view, we're looking at the same thing that we see during an eclipse. We're looking at light scattered off of electrons. This is white light or broadband emission. And so, as you can guess from the flashing box here, during a solar eclipse, we get an opportunity to look inside this gap from the ground. And here we're showing an image from our Indonesian practice run in 2016 that was taken at the same time as these space data. So we don't quite fill in the whole region, at least we didn't with 2017, but we're providing some data from an otherwise empty region where there's a gap. So why is it important to study this gap region? Well, a lot of interesting physics happens there. Maybe it's convenient. When we look at the corona, we can see the solar wind and also coronal mass ejections, plasma blobs moving out from the sun. But in the LASCO C2 field of view, they're moving at a constant velocity. They've already achieved their terminal velocity, if you will. We know on the disk of the sun that they don't move at all. They start from 0. So something happens to accelerate those particles in this region, in the lower corona. And maybe I'm overemphasizing the point, but everybody in the room accelerated the last time you got onto the freeway, right? You start at about a 0 velocity, 0 speed at the top of the on-ramp. And as you accelerate your car to merge with traffic, you go from 0 to 75 miles per hour on the on-ramp. So this part of the solar corona is basically the on-ramp to the solar wind. Particles start at 0 kilometers per second and accelerate up to something like 400 kilometers per second, sometimes even higher or faster. Exactly how that happens we don't really know, and we have very few measurements. And so one of the goals for the CATE experiment in 17, and also for the DEB experiment in 2024, is to measure acceleration in this part of the corona. To do that, it's difficult to do from one spot in the eclipse. An eclipse can last, well, up to 7 minutes, but in 2017, it only lasted about 2.5 minutes at one location. And so what we did is we established a network of sites, 70 sites across the country, from Oregon to South Carolina. And the idea was that if we had data from all of those sites and stitched them together, we would get 90 minutes of continuous observations of the inner corona. And that would allow us to measure velocities and accelerations. Here's an image from the day of the eclipse. It's not quite as bad as it looked. We had some cirrus in the western states. And our heroes from Cienega are under this big blob of clouds in Pawnee City, Nebraska. So we had another blob of clouds in the middle of the CATE string. I'll get back to them in a little bit. What did we do to prepare for 17, and how is it? How are we going to sort of replicate that for 24? This is a really basic schematic way to look at it. About 1,000 days before the eclipse in 17, there was an eclipse in the Faroe Islands in 2015, and we had an experiment run to test some real initial ideas that we had for the 17 eclipse at that time. Then we had a more involved practice run in 2016, which was about 500 days before the eclipse in 2017. So we had these 2 windows to practice and to define our instrumentation and our procedure. That's summarized in the next slide. In 2015, when we were just getting started, excuse me, Fred Isbiner from Carbondale, Illinois, let us know that he was going to the Faroe Islands on his vacation to see the total eclipse. So I remember asking Fred if he'd allow us to ship 2 suitcases of equipment to him, and if he'd be willing to take some data during the eclipse, and he agreed. As I'll talk later, Fred has agreed to do a lot of work. I'm not sure what is wrong with the man, but maybe he enjoys the torture that we're providing to him. So you can see Fred and his colleague here carrying the 2 suitcases that we shipped. The day of the eclipse was not great, but here they had set up the telescope and they were looking at some control software. And in between clouds, Fred managed to capture images of the solar corona. So this was a proof of concept. Fred had never taken an image. He was not an astro imager before this. We sent the equipment to Illinois, and Bob Baer from Southern Illinois University Carbondale had worked with Fred to train him for several weeks. And then Fred was able to take data under really poor conditions. And I have to be honest, this was sort of poor equipment at the time. So we came out of this thinking that we had achieved a major milestone. And in fact, that's how a lot of people responded as well. Things started really moving after we were able to get this proof of concept data. So then in 2016, Fred was also taking data on a cruise ship in Indonesia, but we engaged 4 academic partners, SIU in Carbondale, University of Wyoming, Western Kentucky University, and also South Carolina State University. And here we tested out the idea of having a mini network. So we had 5 locations across the path of totality in Indonesia. And at each spot, we had a faculty mentor and a student, an undergraduate student, with a set of equipment similar, well, improved from what Fred used in 2015. Indonesia wasn't particularly good weather. So we have one site that collected data, and here's another view of some of the images that they achieved. But we again consider this a success because now what we had was a set of undergraduate students that had on-the-job training. And the plan was then to use these students and employ them to train the rest of the volunteers, which is over 200 volunteers for the 2017 eclipse. So we did that, but also along the path of totality, we were still trying to figure out how to set up sites and where the best locations would be. we knew that we wanted sites about 50 miles apart so that as the lunar shadow left one site, it would cover the next site and we can get continuous data. But for instance, I know nothing about Oregon. I've been there twice or 3 times. So I wasn't able to pick out the best locations to observe. So what we did is we established a network of state coordinators in the states where the path of totality crossed. So Mike Connolly from Oregon, Lynn Powers from Idaho, Mike Pierce from Wyoming, Mariana Lazarova in Nebraska, Joe Wright and David Young from Missouri, Bob Baird in Illinois, Richard Gelderman in Kentucky, Mary Kidd in Tennessee, and Don Walter in South Carolina acted as these local experts. And they engaged either the local academic communities or the high schools or the local amateur astronomy groups, and really helped us figure out the details of where each observing site would be and who would be there. Not only that, but we had training programs, and each of these state coordinators worked in conjunction with the students to run the training programs. Here's a list of our collaborators. It's an eye chart. I apologize, but it still makes me happy to see. We had 27 universities joining, 22 high schools, 8 informal science ed museum groups, and then we had people from national labs joining in. And so, like I mentioned before, these groups were assigned observing locations or worked in collaboration with the state coordinators to determine their observing locations. And then we distributed equipment to them during the training sessions. So here's just a few snapshots of the training sessions that we held across the country. Here I am working with the Cienega students in Tucson, and it was about 110 degrees that day. And then in Wyoming, there was still snow on the ground. So I think the training sessions also acted as sort of an environmental test for the equipment that we were running. But the idea again was that the site observers attended these workshops. This is where we gave them their equipment. We had about a 2 or sometimes 1.5 day training workshop, and then they drove off with their telescope and their computers and mounts, and then they practiced. So here we see one of the results from a practice session. Here we had 32 sites, which had varying degrees of success. Some sites had overexposed images of the sunspot, some focus problems and some clouds, and then camera orientation difficulties. But as we kept these undergraduates in the program with summer funding, summer salary, they were working with the state coordinators and then interacting with each of the site observing teams and giving them feedback, letting them know that, yeah, you'll need to rotate your camera another 45 degrees or cut down on the exposure time. And so in the maybe 4 months before the eclipse in 2017, we had several of these joint observing practice sessions, and we had our teams converging on being able to take excellent data with their devices. So on the day of the eclipse, we had sites that had it was a real cross section of America, right? It has to be. We're up on mountaintops in Eastern Oregon, in the plains in Nebraska with nobody around. Hopefully they got permission from the farmer. South Carolina had a site. Some of these are very empty, but then we also had sites that were in the middle of stadiums where the team was surrounded by 30,000 screaming people and trying to collect data. So you can imagine that added a little bit of excitement to the group. But again, we had 70 locations and 280, not 260 volunteers, but 117 students involved in the project. Not only did were we focusing on getting the scientific results, but we also tried to do some outreach, and we had a good team working on this. Measuring the impact of the outreach is difficult, but what we are estimating is that, well, before the eclipse, we know exactly that we had some events at our sites, and we impacted about 17,000 people with the idea of trying to get them to prepare for the totality for the eclipse and understand what it would be like and get their plans in order. excuse me, but on the day of the eclipse, it's a little bit difficult to get numbers because there are a lot of things going on. What I know from my own experiences is that I went to Weiser, Idaho, and with working with the school district for several months in Weiser beforehand, they started brainstorming and came up with ideas for camping near the high school and for having a festival down in town with food and crafts. So I think a lot of our CATE sites sort of acted as nucleuses for events in small towns. And I think we had at least a 300,000 person impact, and maybe more. So that was really satisfying to see that so many people were excited about the eclipse, even in Weiser, Idaho. And hopefully we had a big input on that. In terms of media, we had a big footprint in print, in radio, and in TV. The NASA Edge folks based their broadcast that day from Carbondale, and so Sarah Kovac and Bob Baer were an integral part of that. CBS this morning did a little video clip on CATE Site 17, which had some students from Montana observing in Wyoming. And then about a month after the eclipse, Dr. Heidi Hamill and myself were invited to testify at Congress. So we're on C-SPAN and got some attention from our elected officials. So I hope this works. What I'd like to do is for that testimony, we did a sort of a smaller condensed version of the CBS story. And I'd like to show that here. So let me exit out of this. Oops, I already have it queued up.
Colleague here, Penn, developed an ambitious eclipse program to combine public engagement with science. And I'd like to share a video about several young people in Dr. Penn's Citizen CATE program. When and Alexis Cochran are from a Native American reservation school in northern Montana. They took a road trip with their science teacher, Janet Jorgensen, to watch and study the eclipse. This is just an amazing opportunity for the kids because this is real life science and it helps them be exposed to what kind of opportunities there might be in the future. These students are one of 68 teams nationwide who participated in an amateur science experiment called Citizen CATE. We're trying to get pictures of the solar eclipse so we can study the corona. When the moment finally arrived, darkness descended on the town of JM, and the sight they've been waiting for revealed itself. The total solar eclipse. Before they knew it, it was over. Yeah, we got it. But for these kids from a remote Native American station, 27 seconds stay with them for a lifetime. Something you don't forget.
So those of you who have experienced the solar eclipse know that it's a powerful experience, and clearly Rebecca felt that way. And that was sort of our goal, was to get people, and particularly students, out there seeing the solar eclipse for themselves, and to then associate the feelings that they got with the citizen science that they were doing, to have a sort of a positive connection there. Across, this is one site across our 70 sites. I know that was a common experience, and we're happy about that. With our other team from Cienega, their persistence paid off. It turned out that about 5 minutes before totality, the skies cleared totally, and they were able to get about a minute of data, which filled in a really important gap in our coverage. So here's an idea, here's an image from their site. It's been filtered a little bit to show you the sort of quality. And here I really filtered it to bring out the edges. This is with the Sobel processing. So they, again, were dedicated through the rain and came out the end of the tunnel there with some great data. I'm going to show you a little movie sequence of the Sobel data, but also I'll get to what I've got now. I've had a career change, and so I'm an amateur astronomer now, and it's a challenge to reduce over a terabyte of data in your spare time, as I'm sure some of you know. So I'm still working on the movie, but I'll show you what we have to date. This has been done with a lot of help from Philip Cesarat in Poland and Alexandra Hart. So again, let me try to exit this. And ooh, where did that go? Pull in these movies. And again, I apologize because they're animated GIFs, and across Zoom, there's probably not a whole lot of quality. But this is what I'd been able to make about a month after the eclipse. You can tell that the cameras have slightly different angles, so you can see the edges of the frame going at different directions. But if you look closely down here on the south west limb, you can see an outflow of material. It turns out that there was a coronal mass ejection before the eclipse, and this is the remnant outflow. You can also see some flowing material from the polar region, but then a lot of the corona looks, at this scale, looks pretty stable for the 90 minutes of totality. So in the more recent version of this movie, and this will take a little bit longer to load, haven't really done as heavy a spatial filtering. But again, in the southwest quadrant, you can see, well, first of all, we can see stars now that we've co-added enough of the images. Here's a star moving through the frame as the sun moves against the background stars. But now you can see some material. This is also going forward and backwards through the data, whereas the other one was just a loop going forward through it. You can see some material moving out as remnants of this coronal mass ejection. On the south pole, again, you can see this filament, and it evolves really quickly, or perhaps there's an outflow, still raising a lot of questions. And then a brief little transient event here at the pole. There are some interesting prominences, but if you look at the sun often, you'll know that there are things called H-alpha surges, where you can see a little prominence material from H-alpha going up and then just disappearing or ending. We found out, and the idea was that the material is heated up to 2 million degrees. There's no more hydrogen, it's ionized, so it can't form H-alpha. But here we see an example, a definite example of that. This is an H-alpha surge at the limb. And again, I apologize for the quality of the movie, but you can see some surges through the corona as well. And you can trace the material as it goes from H-alpha temperature, a few thousand Kelvin, up to the 2 million degree temperature in the corona. The big prominence on the limb that many of you saw if you're at the eclipse looks really pretty stable throughout the 90 minutes, as does this coronal streamer. There's another star here. It's a little bit fainter or harder to see, moving back and forth in our field of view. And then finally, one stop at the North Pole. You can see some of these faint transient events or short-lived transient events near the limb of the moon. And then there's a little bit of an eruption, looks like, going out through this coronal streamer. So that's a 60-second tour of our data. There's a lot of science in there. And that was one of the goals of our project, was to get citizen science done. So in 2020, I worked with colleagues and we analyzed the outflows from that coronal mass ejection and published a paper. It's open access, so you can all download a copy if you like in publications of the Astronomical Society of the Pacific. And we do see acceleration. So again, here's the LASCO version at 3 solar radii. The LASCO measurements show a constant velocity at about 250 kilometers per second. And down here near the limb of the sun, we see very little speed, very little outflow, but our measurements at higher heights show an increase. It's not very nice. What we were hoping, of course, is that, here's a constant acceleration curve. if it followed a curve like this, then there would be a 15 meter per second squared acceleration on the material. And it's certainly not that. It doesn't even form a straight line. And this is some ad hoc straight line that doesn't really have a physical meaning. So things are more complicated. And that's the good thing about science, or often the bad thing about science, is that when you make measurements, you open up more questions than you answer. But anyway, I was proud and happy to get this paper published with 286 of my closest friends as co-authors. Check it out if you have time. Finally, no, not quite finally, but as follow-up, we hoped to have several projects going on. The idea was, of course, that after the eclipse, the site volunteers kept their equipment. I'll talk about funding in the next slide. We have generous funding that allowed us to do that. And so after the eclipse, we wanted people to engage in other science programs with their equipment. Mike Connolly, the Oregon State Coordinator, did an excellent job. Here's an exoplanet transit using his telescope and a camera. He took over 2,000 measurements during this transit, and his result was published in 2020. We had some site observers looking at lunar occultations. And so here's a sequence of 3 images as the star reappears off of the dark side of the moon. And then I worked, and several other people worked with students, high school students, and in this case, from Vail. We got several prize awards in the local Arizona Science Fair. So there was some follow-up, but perhaps not as much as we were hoping. And then finally, what was the funding like? It was a mix of private, corporate, and federal funds. So it was very unusual in terms of a science project, and it was just a joy to work with these people. So here's the overall budget for the entire work that we did, which included some summer salary for the faculty as well as the undergraduate students. The breakout here shows the equipment budget, and the rest of it, the education part, was funded by NASA through a generous grant that we were awarded. If we look at the details of the equipment, we see that Daystar, Celestron, MathWorks, and a little group called Color Maker contributed very generously. Daystar provided 60 telescopes, and Celestron provided 60 equatorial mounts. It's just amazing, and I'm still grateful that they stepped in and did this. And then we also had some private donations from people who felt that they wanted to support the project, and some funding from education as well, education groups. So in general, we had 70 sites, and each site equipment cost about $3,500. That was the rough estimate. Okay, so those are the successes that I think we had. But what could we do better is the next part, and the motivation for our next work. I remember looking at some webcasts. I mean, YouTube is wonderful, but it's also provides you a reminder about what you have said in the past. And I remember saying several times that we hoped to have a movie of the eclipse that we could broadcast that night. And so, no one has really taken data like this before with 70 sites. And I didn't realize at the time that the corollary to that is that no one has reduced data like this before. And even though I resisted the celebratory wine and champagne, and everyone was partying in the house where I was staying, I was at my computer trying to get it done. It just was beyond my abilities. So we failed to provide a broadcast, pseudo real-time broadcast in 17. And that's the goal, I think, for this one is, and that's where the name comes from, is to provide a dynamic eclipse broadcast during the 2024 eclipse. And I'll get into details for each of these as we move through the slides. Also, in terms of history, the Continental Astronomy Telescope Eclipse Experiment, Continental America Telescope Eclipse Experiment, the CATE Experiment. You can guess what my daughter's name is from that experiment. Yeah. And with the Dynamic Eclipse Broadcast, you all know what my wife's name is. So I'm happy to be able to work that into it as well. For another goal, in 2024, we'd like to have cheaper equipment. Turned out that $3,500 was, relatively cheap for science equipment, but not as cheap as, not cheap enough so that someone would go out and buy the equipment just for the eclipse. So we're looking at Raspberry Pi cameras and experimenting with those. And we think we have some solutions to get there. In 17, we only had people participating from the path of totality, and that's something we'd like to change. I mean, it's really important to get to the path of a total solar eclipse. As you all know, a solar eclipse, a total solar eclipse is much different from a partial solar eclipse, and it's worth the effort. But realistically, not everybody can do that. So we'd like to have participation from people who are seeing a partial eclipse in 2024. And to make the follow-up work easier, one of the problems that we ran into is that the mount is a little bit beyond a lot of people's skill level, especially beginners in the field. So we're looking at go-to mounts, again, inexpensive go-to mounts, to try to make the follow-up work after the eclipse easier. Here's our plan, and I'll talk about these two events. Again, we're about 1,000 days out, so we've got 3 events planned. We looked at 2 lunar eclipses, and then in about 7 hours, Fred Isbender is in Antarctica with one of our cameras, and we'll see how his luck is this time around. We got some events again, roughly 500 days in advance of 2024 eclipse, 2 lunar eclipses, and then a partial eclipse in Europe. And we hope to get our equipment finalized at that point. And some people are looking at the annular eclipse in 2023 as a way to practice for 2024, but it's only 6 months in advance of the total eclipse. And so that's not enough time to make any changes, for instance, in the equipment or in the software. So that's going to be a bonus object for us, and not something that we're going to try to learn, kind of try to have everything done before then. So for the May eclipse, we had 2 sites. I talked my friend Claude Plymate into trying to observe it with me, and he had partly cloudy skies, but in Tucson, I was completely clouded out. It's sometimes my luck with the weather. But the idea was that we had 2 Pi cameras. We had a baseline of 500 miles, and if we had simultaneous data from those two cameras, we could make a stereoscopic image of the lunar eclipse. We had roughly the same setups, 50mm cameras on the Pi high quality camera. And we're able to sync just with normal network time to 1/10 of a second, which is more than accurate enough. But the weather messed us up for that one. A few weeks ago, we had a larger group, this time 8 people, taking images of the November lunar eclipse. We had some clouds. Mike Connolly was being rained on, and Casterfu in San Francisco got just a few images before the rain started there. But along the southern part of the country, Claude Plymate into Tehachapi had some good clear skies. I had Cirrus again, unfortunately, but Bill Klepping in Greenville, Texas had some excellent skies there. And then Bob Baer in Carbondale was using a different setup, but also achieved some excellent results. So during the eclipse, what we were doing is uploading data from each site at a 1-minute cadence. And so each of us could see how the other person was faring. And that's something that we're hoping to do for 2024, is to have a regular upload sequence. But looking at the images from 2 sites, from Tehachapi and from Greenville, we hope to do a 3D projection. And so here are the 2 of them. Here's from Tehachapi. I've really reduced the intensity of the lunar disk, so the stars are brought out here. But and then because it was only a partial eclipse, you can see an asymmetric glare around the moon. And then Claude had some light cirrus, and perhaps you can see that as well. The data from Greenville, Texas is here at the same time. The image is taken within 10 seconds or so. Again, asymmetric glare. I've rotated it because Bill was using a 105mm camera or lens to feed the camera, and Claude was using 135mm. But you can clearly see that there's some parallax from images taken at the same time in different locations. The moon is in a different spot. So here's our 3D image, and I should have warned people to get your 3D glasses out. But if I use 3D glasses to look at this, I have a little bit of a hard time merging them because I think the 1,200-mile baseline is a little bit too much to make a good 3D image. This will be on our website, so you'll be able to look at it at your leisure later. But we achieved both of our goals, getting simultaneous data from at least 2 sites, and then having a real-time upload to a cloud server. So this past November was a success, and we're hoping to expand our network for the next lunar eclipse in May. But in 7 hours, again, Fred Isbiner, who was our very first volunteer, is still volunteering. He's on a National Geographic boat called the Endurance, someplace off of Antarctica right now. My wife and I had journeyed to Alaska in October, and I'd never seen the aurora, but was able to take a time sequence with this little Pi camera of the aurora. And then we sent it to Illinois, and Fred learned how to do it. And you can see it's very different from the 2 suitcases, right? It's in a Tupperware container now. It's 6 years makes a difference in technology. And here he is practicing with his travel partner, Alan Como, getting a focus for the solar image on board. This was a few days ago near South Georgia. And I think the cruise ship has moved along this direction to get into the path of totality tomorrow, or in a few hours. And the last email I saw was that he was optimistic about getting a clear spot. So we'll see if you can get a picture of the corona with this setup. So we're trying to reduce the cost, like I said before, and using the Pi camera or something similar, we'll be able to reduce the cost significantly, at least a third cheaper, or 2/3 cheaper. So only 33% of the cost of 2017. But if you're sitting in your home and you have your own mount and you're interested in helping out with the eclipse, but you don't want to get involved in any follow-up projects, then buying the Pi camera and the lens and some mounting hardware is probably only going to cost you $400. So we've got a staged sort of schedule for people who are interested in volunteering. And so I think that these are reasonable amounts that people on their own could afford, or maybe a group of people in a club could get together and buy some equipment. Again, we're still working on this. We're still 1,000 days out, but I think we're going to move in this direction, having a low, and it's kind of the way NASA is working now too, right? A low swap camera system, a size, weight, and power, making it very small and miniaturized. And I don't take very good nighttime pictures, but even I could take pictures of M51 and Orion with the equipment that we're looking at. Here's a 100mm f4 Newtonian, and then on the other side of this mount, we've got a 50mm lens. And from my backyard, I could get the horse head. It doesn't show up here very well, but a wide field of view and some nice nebula in Orion. So we're hoping that the follow-up projects, which would likely be occultations or variable star observations or other types of observations, would certainly be a lot easier with a go-to mount and some equipment like this. For the partial phase, we haven't really defined our science particularly well, but I like to think of this figure from the annular eclipse in China. I've been calling this a Bailey beadogram. The Bailey beads are these bright dots at the limb of the sun as the moon, mountains and valleys show parts of the sun or block parts of the sun. So I think the photographer in this case took images every 2 seconds and combined them into this type of format to show you the mountains and the valleys on the moon very in dramatic fashion. Our guess is that if we took these types of Bailey beadograms from different locations, again having a baseline, 1,000-mile baseline between sites, that we'd be able to see some interesting differences. Or maybe during a 3-hour partial eclipse, maybe we could see some temporal evolution as the moon does its libration. But again, we're hoping, or we're planning to have people from outside of the path of totality participate. So again, April 4th, 2024, hopefully is marked on your calendar. Here's the path of totality, but the entire country will see a partial solar eclipse at least. And what we're hoping to do is to provide you with a website that looks something like this, that you'll be able to see partial phases where the eclipse is partial, totality, obviously in the path of totality, and something like real time. And we'd like you to be part of this. So here's my second invitation: is how can you get involved with us? As I mentioned before, we've got a sort of a tiered sort of structure where we have a core team, a group of us now looking at these lunar eclipses and trying to figure out what hardware and software works the best. We have state coordinators who are expert in their local geography and have ties to the local astronomy community and high school groups as well. And then we have site observers, people who are just interested in taking data and being part of the science results that come out of it. So hopefully you're interested in one of these levels. And the way to start working with us is just to send me an email at Penn 2015, or else you can use our group email, deb-initiative@gmail.com. And I don't have a good website now, so I won't show you, but we have a placeholder website, at least, debinitiative.org, and we'll be expanding that very soon. Right, so that's all I had. Hopefully there's some questions that I can answer or comments.
Most of the comments is, most impressive. This is so cool. No comments in particular, or questions in particular, but actually that was the first time for me to see such data from Citizen CATE. It was beautiful stuff, and I can imagine what the full movie will look like once it's all done. But all of that image data takes a long time to deal with, and as one person did comment, that these are very difficult to process like that. So, but good,
yeah, exactly.
Great work, and congratulations to you and the whole team that participated in that. It's just incredible citizen science, I think.
Thank you. And obviously there's no way I could have done it without the help from all those people. It is really cool. It was a lot of fun and a lot of work. So the more people that get involved, we can just delegate and distribute the workload more evenly. And I'm looking forward to working with this group and others who join us over the coming years.
There is one question, though. Does anybody do this in H alpha? That was from Tim Burris on Facebook.
Again, not as far as I know. There have been some small networks of groups, maybe 3 or 4 people, but a large H alpha network would look really cool, especially from places that have partial eclipses. I've said that we're trying to balance the cost with the impact. And H alpha brings us up a level, but yes, I would love to see a set of H alpha observations from partial eclipses.
Right.
I think that's an amazing educational tool to watch those kids. I mean, for everybody involved, the excitement. I mean, to me, that's one of the things this would be about too. I mean, the science part definitely, but watching what the kids, to enthuse the kids and to see this and actually achieve results and to have a paper written. I think that's an incredible project. And it's the first time I've seen anything, seen the end result of what you did.
Yeah, unfortunately I had a little career change right at the end. And so, yeah, you would have seen results much faster if I'd been, employed with my former employer. But a lot of people these days are emphasizing sending people into orbit, right? Go up into low Earth orbit and you see the Earth as a planetary body, and you get a sort of a different awareness, right? We can't do that with everybody, but the eclipse obviously has a big impact. It has a huge effect on a lot of people, on me in particular. So getting people involved in a project like this, enables that sort of different awareness in a much more effective way, I think.
Yeah, and the detail in the images was just incredible. Even though they're GIFs and they're jumping around, it was incredible to see that, to actually see the remnants of that solar mass ejection. You know, I'm an aurora person and I love looking at the sun. And it was amazing to actually see that. So, you know, even to me, somebody that might know a little bit about it, it's still very exciting. I think that's an incredibly exciting project.
It is, you know, one of the first times that this has been done in terms of white light. So I think there are 3 other papers that have looked at the acceleration, but they've used particular temperature plasma to try to trace the motions. But here with an eclipse, we look at all of the plasma at every temperature because it's electrons, just electrons scattering the light. So yeah, it's wonderful that we had that opportunity. You can't really count on a CME, you know, they're very irregular and
Right.
possible to predict, but we had the remnants in 2017, you know, fingers crossed for 2024.
Definitely. Yeah. And you'll have a different path and need different people from different areas. So that opens up the whole field even again. So I would encourage anybody that has an interest in this to contact Matt. I think it would be an incredible project to be part of. And so much fun. Work, yes, but fun, yeah.
All right, thank you.
Yeah. Anybody else got any questions?
Harold Locke says, thanks, Matt. Awesome body of work. So he's watching on YouTube.
Yeah.
Excellent.
All right. Well, Matt, thank you so much. I really like that. I think that will be incredible to see and maybe be a part of. It makes you think about what's possible. So, all right, I am going to share my screen and go back and we'll give the answers to the questions. And let's see. My screen always takes a few minutes to get there. So, all right. The first question, what Messier object did Comet Leonard pass by this morning? It was M3, globular cluster. The winner is Andrew Corkhill. And Barbara Harris, that's a beautiful picture if you're watching. Question 2, there is a famous supernova remnant in Taurus. Name the remnant. And that was the Crab Nebula. And Josh Kovach is the winner of that one. The last question, stars are born in groups, right? Well, yeah, that's true. And Rich Kraling has won a calendar also. So all 3 of you will be winning an Astronomical League 2022 calendar. And somebody from the league will be contacting you about that. And I would like to thank everybody, Scott, David, Carol, Chuck, Don, Matt. It's been an incredible night, a lot of good information, a lot of fun. I always learn so much from everybody that's speaking. So thank you all again for being here. And Scott and I just set the dates for next year. I'll be working on January 21st program coming up. And as soon as we get the information lined up, we will definitely be sharing that with you. And I think that's the end of what I have. I would like to thank everybody that's out there watching and thank the speakers again. It's been a lot of fun. So if anybody else has anything they would like to share or add, this is the time. All right.
You're all quiet.
Yeah, I know when it's that quiet. We're done. So Scott, well, thank you again. Greatly appreciate it. We'll be back in January and everybody have happy holidays, safe time, stay safe. Hopefully next year will be much better and we will see you in Albuquerque.
All right.
Sounds good. Thanks.
Bye, everybody.
Thank you, everyone. Bye-bye.
Bye.
you.